Are you muted, Sundara?
Yeah. So I said I am going live.
Okay.
All
Good
right.
luck, guys.
Yes. Good morning, everyone. Thank you for joining all of us here for the episode 2 of Climate Change Challenge. Climate Change Challenge, most of you probably already know that uh, Climate Change Challenge tries to inspire young change makers, such as all of you, all the young students and teachers, to tackle climate change in your local contexts. How do you find what is climate change? How is it impacting your local ecosystems? Is what this entire challenge is going to handhold you on. The first thing that we do in this challenge is have a lot of discussions with different experts. And why we want to do this is because climate change has multiple aspects to it. It starts from the science, of course, like what is climate change to begin with, and then what are the different reasons of climate change. And it's not like people want to really go and destroy the climate and hence they're doing all of it. There are a lot of challenges. What keeps us doing what we are doing, so and it requires all of us to come together, and that's what we are all doing here. We're building a community of people who are all interested in understanding this problem. And today we are going to have a discussion with Professor Deepa Khushalani from Tata Institute of Fundamental Research, Bombay. Deepa has a very interesting line of research going on in her lab. She looks into cool things such as converting CO2 into ethanol. If you remember our last discussion with Dr. Joy Montero, we had discussed how green gas emissions, and CO2 is one of the greenhouse gases, is one of the major reasons for the increase of temperature. And Deepa looks into how that CO2 can be converted into ethanol, or how hydrogen can be extracted from water and hydrogen can be used as a potential fuel. However, I mean, if there are all of these things that are possible, then why are we not doing them? We're not doing them because there are still a lot of challenges in being able to do that. And Deepa is going to be our expert who's going to tell us a bit about all these energy sources that are available. She's also going to talk about the challenges in being able to use all of that. So that's what the session is going to focus on today. The main objectives that you will listen on is what is energy, why it is important in our lives, what is the impact of the choice of energy sources on climate, and what are these different energy sources. We are going to call them renewable and non-renewable, and how do we make a choice of what energy source we can use in our lives. Uh, in this session, there will be Gayatri and Saket. Both of them are PhD students. They're ecologists. They are PhD students at Laboratory of Conservation of Endangered Species. That's in the next lab of CCMB. Gayatri, can you wave, please? So Gayatri is going to moderate the discussion with Deepa. And Saket, can you please put on your video? Yeah, Saket is going to, you remember, right, from our last session, we do have quizzes and games in our session. So Saket is going to moderate those sessions. And today we are also going to have calculations, pen and paper, simple calculations for you to get an idea of the energy crisis. So get your pen and paper in front of you when you are going to do this while you are sitting for this session. And for the game, I will repeat that it is easier to play the game on a laptop or a computer instead of a smartphone. So if you have access to a laptop or a computer, please do use that. Over to you, Gayatri.
Hey, so good morning, everyone. I have been very excited to start discussing energy and climate with Dr. Deepa. So, Deepa, I was while preparing for the session, I was reminded of our physics chapter. I think it was a 9th standard chapter named Work and Energy. So, I was wondering. I was not very good at physics. So I was wondering if this session is, we're going to talk about energy as a physical concept or just in short, like why are we talking about energy with climate? Like what is energy? So that's going to be my first question to you.
Okay, that's a very interesting question. Thank you. First of all, I want to thank, before we get started, everybody at CCMB, and especially obviously Gayatri and Somdatta and Sakit for organizing this. I think this is fantastic for all the students and for all the audience members, guys. I hope you appreciate what these guys are, people at CCMB are trying to do. I think it's fantastic outreach effort. Anyway, so let's get started on energy. What is energy? That's a very complicated, it's complicated and it's simple at the same time. Obviously, and most people know that, we have things like kinetic energy, potential energy, or mechanical energy, chemical energy. These words I'm sure students are familiar with, but I want to try and think of it as a unit, as some sort of just like we think about money, money is something we want a lot of in our lives. Okay, everybody aims at getting a lot of money because with money we can buy other things and we can make our lives better. So by the same token, think of energy like that. Think of energy as something that we want a lot of, because when we have a lot of energy, it will make our lives better. Okay, and it could be different kinds of energy. The best part is we can convert one kind of energy into another kind of energy, but it's sort of some sort of a little, not something that we can hold, but it's some sort of how should I say, entity that everybody, every country, every government, every, at a state level, at a federal level, at a central level, as a continent, as a society, we want a lot of energy. And I'll try and explain how we get this energy. The problem is getting this energy is what leads to a lot of climate change. And so hopefully, if you're okay, we can get started with my slides, or you want to ask more questions, Gayatri?
Yeah, so this point I'm very interested in, like you were saying that there is a lot of energy around us in terms of we use energy for everything. Like there is energy in producing food, there is energy in making clothes, and for shelter, transport, everything. So like I was curious, like before we identified or discovered the sources of energy that we're currently using, what do you think like people like ancient prehistoric people might have used for energy?
Okay, so one of the earliest uses or sources of energy was, I can think of as wood. Okay, lakdi in Hindi. You cut down a tree, you have wood, you burn wood and you get fire. And you get heat from the fire. So if you're cold, that fire keeps you warm. Okay, so that is thermal energy coming at you from that fire. By the same token, you can use the fire to cook food. So that source of energy, which is wood, and it only releases the energy when you burn it. Okay, and you need oxygen to burn it. And then you can cook food onto it. So it releases, and you're allowed to convert that energy into chemical energy. You understand, the food that you eat gets cooked. When you eat that food, it gives you energy, right? So you're transferring that energy into chemical energy when you digest, and the chemical energy gets converted, and you get, and then you become stronger, and then you can lift, you can cut down the wood to cook more food and to get more fire. So perhaps from prehistoric time, that would be one thing. Coal is another aspect that was used, that comes to mind. But there are other types of energy that we can talk about. But right now, I think these were the most two common ones that were used prehistorically. Historically.
Yeah. So I think we can start with you talking about how energy is important for our standards of living.
Okay.
All of that. Yeah. So you can start.
So one thing I want everyone to keep in mind is that, remember climate change from your previous talks, or in case you're not familiar, the most important chemical in the world that contributes to climate change is carbon dioxide. Okay. And so whenever you're looking at any of the slides or whatever I'm saying, keep at the back of your mind is, how are we going to generate more carbon dioxide? If we generate more carbon dioxide, it will lead to more climate change. Or how do we remove carbon dioxide? And if we remove carbon dioxide, it would try and circumvent climate change to an extent. Okay, keep that at the back. so that you'll understand where all my slides are going. So in this slide, I'm trying to show you something that is perhaps commonly known. We know in India that we are the second most populous country in the world. Okay, this is a slide from 2018 and it's showing it as a percentage of the world. They're showing China currently has 18.7% of the population of the world and India has 17.88%. That 17.88% is approximately, as all of you know, around between 1.1 and 1.2 billion people we are in this country, in India. And that is currently around 2018, 2020. This is important because I want you to see how large our population is with respect to the rest of the world. Okay, we are not just a little bit higher than the rest of the world. China and India are huge in terms of population. Now I want you to see what happens in about 40 years or 45 years, okay, which is in your and my lifetime. We will all live another 40, 45 years to an extent, okay? And I want you to see what happens to our population in India. India is going to surpass the rest of the world substantially, okay? We're going to be having around 1.6, 1.7 billion people in the world. And China will be much less than that because they are practicing family planning and population control. India does not do that, which is fine, it's okay. But I want you to see, now why am I bringing population into this, all right? We're talking about climate change and energy, but what am I talking about population? The reason I'm talking about population is because it will affect our country the most because we have such a large population compared to the rest of the world. Now I want to talk about something else. We have a large population, but we have to take care of this population as well, okay? So what does it mean to take care of this population? It means as a country, we all want to be wealthy, right? We want to have good literacy, good education. This entire population that is increasing and increasing at a faster rate than any other country in the world will have to be given education. This population will have to be given a large amount of medical attention and healthcare issues associated, to keep it healthy. We do not want a sick large population, we want a healthy population, correct? So we have to make sure there's enough facilities available so that their health is maintained. We have to also ensure that this entire population is fed well, means there's enough food for this very large population. Now, all of these things decide on how good the country is. And there's something called, which is written here in the y-axis, it's called the Human Development Index. Okay, so this is something that the United Nations has come up with. It's sort of a benchmark as to how good a country is. If a country has good life expectancy, means it has good healthcare. If it has good literacy and school enrollment, if it is relatively wealthy, the GDP written here has to do with wealth, how wealthy you are as a nation. If all of these things are on a high level, then the Human Development Index has a higher number associated with it, okay? And as you can see, there are countries here which we all know are very nice countries. A lot of Indians want to migrate to these countries. And now you know why, because they have a good Human Development Index. Canada, USA, Germany, all of these things are here. What I'm not showing you is something on the y-axis. What is the Human Development Index dependent on? Why do certain countries have a high Human Development Index and some countries like India, as you can see, is on the lower side here? And it's sort of an interesting thing on the x-axis. I'm showing you how much consumption of oil or consumption of energy these countries do. So it's showing you per capita, by the way. Per capita means per human being. So it means, therefore, that if you want your country to be healthy, you want your country, your population to be literate, to be educated, you want your country to have a high GDP, wealthy country, then you need to spend more energy per person. And remember, India has a huge population to begin with, and that population is only increasing. So the demand of energy for India is going to be huge. Not not only to maintain itself at this number, even just to maintain itself at this number, it needs to start spending more and more of our energy because our population is increasing. But if we want to move up this curve and go up on the y-axis, then imagine how much energy India actually needs to spend. Think of it.
So Deepa, that
sorry, go ahead, Gayatri.
yeah, so that sort of answers my question to you, like why is energy such an important thing for standard of living or for improving the way we live on a day-to-day basis. So that is a very clear graph, I would say. Now, another question that I was thinking of while you were explaining the first few questions is like, how do we actually produce energy? So you mentioned coal in one of your slides. So I was interested to know, how do we actually, like I've also heard from school that you produce energy from coal. Now, how do you produce energy from coal?
Okay. So I'm just going to have to move. I will just show a little bit and then can I come back to that answer? Because I want these few slides I'll just sort of mention. This thing is valid. What I was saying about India is correct, which is that from 1990 to 2016, therefore in this 26-year period, the energy used, okay, increased 1.8 times. The Human Development Index did increase, okay, from 430 to 630, but the CO2, our country, the amount of CO2 from 1990 increased 2.5 times. So you see there is a direct correlation. We as a country got richer, okay, from 1990. I'm sure some of you may have been alive, some of you may not have been born then, but you can talk to your parents and you will know that how life was different then and how life is now. And this is directly relating to climate change, okay? So on one hand, we're having a more comfortable life, but we are contributing to climate change, all right? Sorry, and so by the way, I forget my mistake. I have played with too many. So, you know, you were saying what is energy? So we need energy in all of these things, from transportation to irrigation to lighting our cities, to when you watch your TV, to when you fill your car and you recharge your laptops and phone, to when you're eating. All of these things require energy, okay? So the other thing I want to sort of, I will come back to coal, but I want to say why that is such a huge problem for India, okay? I want to highlight this slide so that no one is under any false ideas that India does not spend a lot on coal. We spend a lot of our electricity is generated from coal, and this little pie chart here, as you can see, 75% of this pie chart is in black. And it's telling you that as a country, for India, 75% of its energy is coming from burning coal, okay? And this is called a coal thermal power plant, all right? This is what they look like. They're all over our nation. We continuously build new ones. And these sort of power plants, this is steam coming out, all right? And CO2. What you see coming out here is CO2 and steam, water vapor. And this is what is the problem, a large problem of our climate change, because we're burning coal in these power plants.
Deepa, so I think my question to you was more like what happens inside of these
things,
power plants.
Right. So I will just show you what happens inside. Just 1 second, I'll go to that slide now. So when we burn coal, so what is coal? Coal is made up of carbon, or it's a type of a carbon-based fuel, okay? When you have a carbon-based fuel, so here's a little bit of chemistry. I don't want to bore people. If you are too young to understand these chemical equations, it's okay. But what I want you to see on the left side is there's a molecule with carbon in it. In this particular case, this is methane. It can also be coal. If it's just coal, then you would just put carbon, like you would put it like this. CXHX, okay? Coal is mostly carbon. There's a little bit of hydrogen in it, but you would put it like this. And what happens is when we burn it with oxygen, Just like wood, remember when you want to light a piece of wood, you need oxygen. Also with coal, you need oxygen and you burn it, and there's a lot of heat that's generated, and that is the main thing. All right. This hydrocarbon, when it burns, gets converted to carbon dioxide here. All right. So for every single molecule of carbon here, or every single atom of carbon here, we get one molecule of carbon dioxide. Okay. So if I have 20 carbons here, I will have 20 carbon dioxides here.
And this water vapor will be like at very high temperatures, and it'll be in the form of steam.
Yes, yes.
So,
this is what, yes. So now this basically gets converted, this steam, okay, this energy gets converted into driving a turbine engine inside the coal power plant. And that turbine engine, all right, basically when you apply heat, it sort of turns like this. When it turns like this, it gets converted into electricity. So the heat that you see here, okay, drives a sort of a mechanical entity. This energy gets converted into kinetic energy of the turbine engine. That kinetic energy gets converted into electrical energy to give us electricity. Okay, so that's just the mechanical aspect of the power plant, but the main thing is the heat that's generated, and there's a lot of heat that is basically used to convert it. So it's thermal energy that's converted into electrical energy.
So Deepa, I think from this first part of our question answer discussion sort of thing, I get that India uses a lot of coal, and we burn it and create steam to run the turbines to make electricity, and like it releases certain gases like carbon dioxide and such. And definitely energy is very important to maintain standard of living. I think this is a good point to take a break for us.
Okay.
So I think we'll have our first quiz at this point. So over to Saket. Maybe Deepa, you can take a short break while we do the quiz.
Okay.
Yeah, so it's a 2 minutes break.
You want me to stop sharing the slide?
No, not necessary. You can also stay online with us.
Okay.
Yeah. So Saket will be sharing his slides to show how to do the quiz. So you might want to take your slides off, but you can be online. Watch the quiz. Yeah. So over to him.
Where is your, it's here, huh? No. So hello guys, can you see the quiz? I hope you people, all of you got the link for the quiz. So I'll give you a minute to figure it out. I want you to answer all the questions. Some of the questions are from last session. Some of the questions pertain to maybe Deepa can also have a try at these questions. So I'll just give you a minute before I tell you the answers. So let's see, I'll give you a minute for this. So the questions go like global warming primarily is concerned with the increase of wind. The options are carbon dioxide, sulfur dioxide, ozone gases, and nitrogen and hydrogen. Second question is what is energy? Anything that has mass and occupies space. Is it so? There's an option also. It's a tricky question. Could be all of the above as well. Third question is which sector produces most energy in India? This one, if you have been paying any attention to this talk, you should get it. Okay, this one you should know. In India, what we use for most of our energy. Which of these are source of energy? Coal, wind, solar. And yeah, this question I think is very interesting. Like compared to India, what do more developed nations like the USA consume? So Somdata, are we getting some answers in? I can't hear her. Are we getting some answers in? Gayatri? Okay. Okay, so let me know, then I will go to the answers. We'll give them a minute, I think. Guys, I hope the link is working well. Yeah, you would have got the link on the YouTube chat. It's a simple questions, guys. Only one answer, not multiple choice and all. So should be able to get it all correct. I'm hoping you get all of the questions answers correct. You just need to click on the link and just fill out the form. I hope you're enjoying the talk till now. Like probably one of the more important aspects of climate change is that we need energy to do our work, but at the same time, how we produce our energy, we need to understand the costs associated with it. So really interesting to note till now that we use so much coal for our energy and the problems associated with it. And there were many comments asking about what can be done about this, what are the alternatives, and in this talk we are going to touch on these alternatives, and we hope that we will get an idea of what is the scenario of energy use and what do we do moving forward. So this quiz is like a little bit, for you people to keep fresh, right? So that you and also it reiterates some of the more important points. Um, should I go ahead, Samdata? Okay, good, good. Yeah, let me know. Meanwhile, guys, while you're doing this, I hope you all did the homework as well. We have sent a small homework for you to look at what are all the appliances that you use in your home and how much power they use. Uh, Let me tell you, I did the same exercise myself. I felt very stupid. I did, I myself came to realize how much energy I'm using and what are these implications. So we're going to be having a small calculation later on, in which we try to talk about what exactly is this, how much energy we use, how much, what is being used to generate that energy. So hope that would be interesting for you guys. And yeah. Also, Deepa, when in your discussion, I was fascinated to see that the HDI is so dependent, like all the richer countries use so much more energy, and really shows the link between.
Yeah, it's just a link. It's not a definite equation that says one. It's people were trying to say what do the rich countries do differently and how come they are better at it. And it turned out one of the main things is that they do spend more energy per person. Where they get that energy is a separate thing.
Yeah.
Okay.
And
it's
what they
not
do
like
with
those countries are also burning coal. They have a different ratio. I can show you that data. That is different.
Yeah, that's true. That's true. Yeah. Yeah, that's some data maybe you can show just before you move on, right?
Sure.
About what are the other countries using. I think Gayatri was just trying to push you along a little bit because we want to fit it within the 1.5 hour.
I understand. I understand. I don't mind.
Yeah. And about the historic sources, I think there was one thing which I felt you didn't mention is animals. Like we used animals for a lot of our work, like for plowing the fields, and we still do, I guess, but in terms of energy that we use, like muscle power.
Muscle power,
today
yes.
We use electricity for everything, so we think on those terms. But I think like historically, muscle was just like food. Like we eat food and.
You see, but you need to feed them as well. You see, with wood, in the beginning, people didn't do plantation. They just did cutting.
Plantation. Plantation was,
So with animals, yes, the cows and the horses, to use them to our advantage. Yeah.
All right. All right, guys. I hope Somnata, you can just update me on if people got it right. I'll pause after I tell the answer. So for the first question, guys, I'll read the question now. So global warming primarily, guys, here the keyword is primarily, is concerned with the increase of which gas in the atmosphere. So the answer for this is carbon dioxide. I hope most of you got this right. That's great. That's great. I'm happy. So the second question is energy is what? If you guys said energy is anything that has mass and occupies space, then that is matter, okay? Like that's the only thing, like an event where two surfaces rub against each other is not energy. It's just a friction, right? Friction that produces something. Energy would be defined as the ability to do work.
Yeah.
Sundata?
And 63% of you have gotten this right. I must say that 25% of them thought that it is all of the three above.
Okay. So that's a trick, guys. That's very important to know when we talk about energy, what it specifically means. Here, energy, when Deepa was talking about as a unit, right? So, in terms of units of, it gives us the ability to do certain things. So you need to be very specific when we talk about such things, and that's why we put this question in. For the third question, which sector produces most energy in India? 75% of all the energy. Coal plants, nuclear plants, hydroelectricity, wind energy. We have all of these in India. So which sector do you think produces the most? It is coal power plants, and let's see how many of you got it right.
70% of them have gotten this correct.
And what was the popular wrong answer?
The popular wrong answer was nuclear power plants and hydroelectricity.
Yeah, I think nuclear power plants and hydroelectricity get a lot of attention because there are some new things that are being built up and we hear about it. But it's very important to know that it's the 300-year-old coal that we have been depending on is still the dominant source of energy, even though if there are nuclear power plants, even there are nuclear energy. So it's important to know that that we have to progress going forward in this. The next question is which of these are sources of energy? Coal, wind, solar, and all of the above. So again, if energy is the ability to do work, coal, wind, solar, all of them can be converted into useful form of energy. So the answer is all of the above. And let's see how many of you got it right.
84% of them have gotten it.
Oh, that's great. That's great. So I think you people got an idea of what is energy and that all of them can be used for it. For the final question, as compared to developing nations like India, more developed nations like the USA consume more energy per person, or do they consume less energy per person, or the same, around the same amount, or do they not consume any energy at all? As Deepa was showing, these countries, they also have their high standard of living, because they produce and use a lot of energy, and also the negative effects they have to contend with. So the answer is more energy per person.
Yeah, I think this is something that is still confusing for our people because, though 43% of them have picked the right answer, which is more energy per person, a lot of them think that they use either the same amount of energy per person or even lesser energy per person.
I think, guys, the important thing here is it's not overall energy, the whole population. Of course, other countries have less population, but if you see per person, they use a lot more energy. Like they use more fuel, they use they use more appliances. They have a higher standard of living because they use a lot more energy for their day-to-day work, transport, etc. And that's why it's alarming because countries like India and China, we want to get developed. We want such a high standard of living, but we have populations that are like 10 to 100 times the size. So it's really critical that as the large users of energy and as we need more energy for the high standard of living, we have to be very careful as to what are the sources of energy we are using and what impact it has on the environment. And I think going forward in the session, we might reiterate this point and also talk about how the energy split is and then continue with the talk. So let's see, submit. And yeah, so there I go. I submitted it as well. I'll get back to Gayatri to continue the session.
So, hello, Deepa.
Yeah.
You saw the quiz. So in the meantime, while Saket was conducting the quiz, I could also go through a few comments in the YouTube section. So I really think that we have some really smart students today for the session. So one of the students, Supriya Chandra, she was asking, yes, coal is good, but then is it not exhaustible? She was asking, shouldn't we use something better? So,
yeah.
yeah. So I wanted to start the next session asking if why is coal exhaustible? Is it like, what is it? Like, is it non-renewable, as they call? Why is it non-renewable a resource?
Okay. So yes, coal is definitely something that is called non-renewable source of energy. It does not renew itself simply because we have to mine it. Okay. It sits under large mountains. We have coal mines. I can show you this data may be a little early, but it's all right. I will show you this slide that sort of tells you how much coal there is. I hope you can see the slide of how much coal there is in the world. This is a slide that shows coal is shown in the yellow, sort of this orangey yellow histogram, okay, around the world. And as you can see, the size of these yellow ones are quite high. Oil, which is in red, and natural gas, which is, these are all non-renewable sources of energy. These are all sort of sources of energy that we burn and we get some form, either we use it for transportation or we use it for electricity. And you can see how much of it is around the world. Oil is predominantly in the Middle East and South America, and coal is in these other countries. And there's a large supply. Question is, how long will it exist? How long before we completely deplete it, finish it? Well, it depends on how fast we use it. If we don't start using other sources of energy, and if we continue to rely on coal, then we will start depleting it at a faster rate because our population is increasing, okay? Our population is not staying stagnant. So our coal consumption will increase with time. And if our coal consumption increases, then this coal yellow histograms will start going lower and lower. And there is some idea that maybe we have another 80 to 90 years worth of coal left if we continue at the same pace. If we increase our pace, then there is less coal left, okay? But there's a bigger problem, as we've already mentioned. All this coal burning is releasing the greenhouse gas, the CO2, which is a big problem. Also, when we are burning oil and natural gas, there's less natural gas in the world. There is less oil in the world. We are using it up at a pace. Question is, how fast are we using it up? And that will determine how long it lasts. But whether it lasts 10 years or 50 years, when we are using it up, we are releasing carbon dioxide. Okay? Is that all right?
Yeah. So Deepa, so by non-renewable, like I understand, like you showed these graphs saying that we have, if we continue at the same pace, maybe it can last like maybe 100 and 150 years or something, or if we pace up, maybe not even till then. But what I was thinking is, like, you mean to say that we cannot make coal again? Like, coal was produced by certain long drawn geological processes. Like, I was reading up, and I found that all these fossil fuels, they took around 200 million years, it seems, to be formed. Yes. So it is they're called non-renewable also because it's not easy for us to make them again.
Yes, sorry, yes. I didn't make that clear. Yes, you're absolutely right.
Yeah, that's fine. So now that brings me to the next question. Like, you showed us the equations where you showed that if you burn any hydrocarbon, like, it produces carbon dioxide. And from our previous session with Saket and Joy, we saw that carbon dioxide traps a lot of heat. So it is a greenhouse gas. So now I get a point, a clarity as to why we have linked energy and climate climate change. So can you please explain to the audience how it creates global warming, or why is coal bad for climate or our planet?
Okay. So I have sort of shown a bit more detailed equation here for some of the students who are interested. So you can see the kind of energy that is released when burning methane. All right, that's another hydrocarbon fuel. Now, so you can quantify. So this is a lot of energy that gets released, all right? And that is why we use hydrocarbons, because it's in the bond, the carbon-hydrogen bond, or the carbon-carbon bond. When we break this and we form this CO2 gas, okay? So now you want to know, sorry, the question that you're asking, Gayatri, is how does CO2 contribute to global warming?
Yeah, yeah. So
okay.
Why is coal bad for the planet?
Why is it so bad for the planet? Okay, so this is the definition of what a greenhouse gas is. Okay, it sort of is a gas that traps heat from escaping. It's sort of a latent heat. It increases the temperature of the planet. It's very hard to explain it if you don't understand. You know, I tend to use infrared spectroscopy because that is where a lot of the science is based. But basically think of it like a heavy gas, all right, that is shrouding the planet, and it prevents the planet from cooling down. Okay, for lack of a better way of explaining this, it sort of doesn't dissipate away. This is a gas that is not a nice gas that sort of traps the heat that normally sun is shining down on us. Not all the heat reaches the planet, but in this case, it sort of traps the heat, all right? And it sort of allows our temperature of the planet to keep increasing. We feel hotter when there's more CO2 around us, okay? It has a lot about what sort of energy it absorbs and what sort of energy it doesn't absorb, as opposed to other gases. But CO2 has a certain type of absorption ability that it traps the heat and it doesn't let it dissipate away. And that is why.
So the short of it, the long and short of it is, I think that coal burning any kind of fossil fuel releases a lot of greenhouse gases, which is why it contributes to the warming of the planet. Now, one very interesting thing that I want you to discuss with the students is that, like, I've seen that usually people get confused between global warming, pollution, and climate change. What happens is, most of the times they think that pollution is equal to climate change, or pollution is equal to global warming. So for them, like, when I was a high school student, like, for us, climate change, the first thing that we would write about or think about is pollution. So, like, maybe I know that all of these are interrelated, but probably you should simplify it for them, like making them know what is the connection between pollution, global warming, and climate change, so that it'll be simpler. We can think of other things when we think of climate change.
Okay. So in my opinion, climate change is exclusively related to global warming, means the temperature of our planet is increasing. All right, that is it. That is what climate change is. When the temperature is increasing, our birds and our living things, our plants, us as human beings feel a higher temperature and we're not happy, and there's some other issues associated with it. But there's one thing I want you to see here is this picture, little picture that you see on the top right corner of these cars, all right? And you see it's a hazy day. Now, it's a hazy day not because of this is fog, this is smog. So this is a kind of pollution, okay? But this pollution has come because we are burning coal, because we are burning non-renewable sources like petroleum, like gasoline, okay? Like burning natural gas. When we burn this, and if we don't do what is called complete combustion will allow me to give you basically CO2 and water. Complete combustion means this reaction that I'm showing you here goes completely over here. I only make CO2 and water, but I can do what is called partial combustion, which is inefficient combustion, When you have inefficient combustion, you don't only get CO2, you get carbon particles that are floating in air. Okay? It's sort of like a different byproduct. Complete combustion means there's a less of oxygen to drive this reaction here. Okay? When you have less oxygen, so you make different products. The reaction is not balanced. And this is what ends up happening, where you get other kinds of pollutants that are deposited. And one of them are called hydrocarbon or suspended particles. Okay, and that is what leads to a hazy day. Here you see Beijing in China, what we call smog, which is on the left side, and on the right side is what it looks like without smog, what a clear day actually looks like. So you see, these are carbon particles. So this is pollution. This is not climate change per se, but climate change is associated with this because we release CO2 as well. Remember that. We've released CO2 on the left side, but we've also released carbon particles. We've released these other gases, greenhouse gases like NOx and SOx, NOx and SOx and things like that. And those gases cause pollution. In this case, I'm showing you air pollution. So air pollution has other effects, which is health effects. We don't see things clearly. People get asthma, people get respiratory diseases and so forth. All right. So that is what pollution is. In some respects, if you can deal with pollution, air pollution, you're also directly dealing with climate change because you are preventing not only carbon particles from forming, but hopefully also from carbon dioxide from forming. So people who talk about pollution also talk about climate change simultaneously because they are related. Because the same kind of chemical reactions are contributing to both.
Yeah, so this makes it clearer for me. We'll get to know from the students in the comment section what they think about this. And yeah, so this is what, like I was thinking, like this is why we can see stars in the village areas and not much in cities because of a lot of suspended particles. They kind of block our the light from stars coming to us. Yeah, so Deepa, one more question that I have here is what I have also listened to a lot from climate change, anti-climate change enthusiasts is like you have to strive to reduce your carbon footprint. So now that we have been a lot about carbon. So what is actually carbon footprint? Like, how do we reduce it? Like, what's actually carbon footprint? That's my question. Next question.
So carbon footprint is basically how much carbon are you using to generate your energy requirements, for example. Okay. So where is your energy coming from? And if your energy is coming from using non-renewable sources like oil or coal, then your carbon footprint is going to be large. Okay, means you're using a lot of carbon. I'll give you an example just to show you this little slide. Okay, so this is basically how other countries are deriving their energy requirement. So if we just look at the coal footprint, so we can use an example of coal footprint. You will see the world's coal footprint is this size here, for example. And in India, the coal footprint is this size here. And in China, the coal footprint is larger. USA, the coal footprint is smaller. But USA uses more oil than India does. Okay? For India, coal is cheaper. Oil is more expensive, so we use different amounts, whereas USA uses a different ratio of coal to oil. So these are their footprints associated with the non-renewable resources. That's an easy, as a whole country, that you can sort of see. Okay.
So basically it is to simplify the whole thing, I would think of it as how much of greenhouse gases that you probably emit on a day-to-day basis. While so if you emit less, that means your carbon footprint is less. And if if your activities produce more such gases, it means that you have more carbon footprint. So,
Yeah.
Deepa, one more thing that I was thinking, like since you were showing a lot of cars and such in your slide explaining the smog, it made me think that is it like if only I own a car or something, is that like I'm going to use coal on a day-to-day basis, or like how do we know that how much coal do we use in our household? Like coal, electricity is formed from coal, so probably our electricity bills might reflect how much coal we use, is it?
Yes. So if you are deciding how much of, you can calculate for yourself how much of a carbon footprint for you to exist on this planet you are using, okay? How much non-renewables. So as I showed you, for a country like India, this is our ratio, at least when it comes to electricity. This was for electricity only. So as a country, we use 75%. So means that every time you plug in your phone into the electrical socket, every time you switch on the TV, every time you switch on the electricity in your room, the light bulb, every time you are opening your fridge or using the microwave in your house, all of these things require electricity, and therefore 75% in principle daily use of your electricity is coming from burning coal. So you can decide, you can calculate how many watts of energy you have used, okay? If you calculate how many watts of energy you have used, you can use simple equations to work out how many grams or kilograms of coal has been burned to generate so many watts of electricity. And if so many grams or kilograms have been burnt that day for you, you can therefore see how much CO2 was emitted that day, so that you could watch your favorite TV show, so that you could sit and talk to your friends on your phone, how much you use to, eat the ice cream that you put in the fridge, sort of thing, and you can see how much that contributed to climate change, to global pollution or air pollution, because CO2 and other gases were released. All right.
So
It's not a very nice sentiment. Okay, I don't want to depress the people, but that is a fact of life. And what we really want, and I hope we get to the conversation, which is how do we minimize this black? Are we going to be sitting with this 75% thing for the rest of our lives? Because it doesn't make for a very mentally happy frame of mind to exist on this planet if we continuously see so much pollution being released, right? But can we as a society change that?
Yeah, so I think that is a very interesting discussion that we'll have after Saket, Somdata, and like we had discussed this with you also. We had given them a homework to find out the most used equipment in their houses, and probably I'm expecting a few answers in the comment section of the YouTube. So I think Saket will walk them through the calculation, like how can you calculate how much coal do you actually burn by using equipments in your house. So after that calculation, probably to our shock, we'll realize why is it important to transition to using renewables. So I'm again handing it over to Saket.
Okay.
We'll do the calculation, and then later we'll have a discussion on alternatives. Saket?
Unmute yourself. Can you hear me, guys?
Yeah.
Is it echoing or anything? No, right? Okay. So now we are going to do this really interesting. Let me share. Can you see the questions? Gayatri? Am I typing? It's coming? Yeah. So guys, we had asked as a homework to see how much energy the appliances we use. Today we are going to do the small assignment. We have these 3 questions. So let's start with it. First question is, how much energy is required to light a 100-watt bulb for 1 day? Okay. So a watt is a unit of power. All right. So let's try to see just one bulb. how much energy we use. And later we will go and find out to produce the amount of energy to run one bulb, how much coal we burn. All right. So for the first question, let's see, 1 watt is equal to 1 joule per second. All right. So basically, if you use 1 joule per second, that's equal to 1 watt. Okay. So if you have 100 watts, that's 100 joules per second. Then 1 day, let's see how much is 1 day. We need to calculate how many seconds a day has. So I'll go use my calculator. Guys, I don't know if you have used calculators. There's a very fun scientific calculator where you can use things like sine, cos, tan, Please do check it out. But I'll use the basic calculator. And we are going to calculate how many seconds are there in 1 day. So we have 24 hours into 60 minutes into 60 seconds. So we have 86,400 seconds. And that would come to, so in for 100 watts in 1 day, basically how many joules of energy do we use? So we use 100 into 86,400, which is 86,40,000 joules of energy. Okay, or 1000 joules is 1 kilojoule, so we can call it 8,640 kilojoules. Okay, so basically that's why we have calculated that. Okay, if it's 1 watt, we know it's 1 joules per second, and how many seconds in a day, and we just multiply it, and we have 100-watt bulb. So for 100 watts, how much? So we get this. Now you can do the same thing for your appliances. I encourage you all to see how much energy your appliance use, because for example, a fridge is like 1,000 watt, and you run the fridge whole day, so that would use 10 times more energy than this. Or an AC is like 5,000 watt, so you can multiply, you can imagine it's 50 times more energy than this. So basically, if you know the watt power rating, like how many watts your appliance uses, you can easily convert it into joules per second and just see how many seconds and get a value of how many joules. All right. Now we'll go to the second question where we go from joules to how much coal. Okay. So if you see the second question is like, okay, let's assume that the source of this energy is coal. Now, coal, 1 kg of coal gives 300 lakh joules. All right. Yeah. Yeah. Yes, yes, sure. Okay, just hang on. Oh, what did I just do? Not this. Just
Right below bottom bar of your Microsoft Office, you'll see a percentage, 70% or so.
is this fine?
Oops.
Okay, just hang on.
No, not that. The number where you see that slide.
Yeah, I got it. This is okay. So basically, guys, we came to like 1 watt is 1 joules per second. So 100 watt is 100 joules per second. We have this many seconds in a day. So we use 8,640 kilojoules of energy to power a 100-watt bulb for 1 day. Now we're going to do the second one. Okay. So let me just take it to a new page. So okay. So 1 kg produces 30,000,000, right? 30 into 10 power 6. So 10 100. 10 power 6, right? So this much energy, right? So we can just make it 30,000 kilojoules, right? So now, but the coal power plant is only 30% efficient. Not all the coal ka heat directly gets converted to turbine. If you remember, madam was saying that the coal is converted to smoke. The smoke runs the turbine. There's a lot of wasted energy that dissipates. So, and then finally, the electricity also, there's a lot of energy that gets dissipated. So typically, your power plants are also only around 30% efficient. So even though 1 kg of coal should give this much energy, actually only 30% of it you get. So how much is 30% of 30,000? We have 30 by 100 into 30,000, right? So basically you have 0, 0, 0 cancel, and you have around 9,000 kilojoules. Okay, so we get around 9,000. If you see that, so you see that you get the 30,000 kilojoules
from 1 kg of coal. Okay, but if you include efficiency, right, you get only 30%, so you get 9,000 kilojoules from 1 kg of coal. All right. Now, when we go back to the previous one, how much energy? Around 9,000 kilojoules is what we use for running a bulb for 1 day, right? We got 8,640, and 9,000 kilojoules is what you get from 1 kg of coal. So, if how do we calculate how much coal we use for running it? It's basically 8,640 kilojoules needed for the power by 9,000, which comes to around 0.96. So 0.96 kg of coal, that's almost 1 kg of coal we use to run a simple 100-watt bulb for 1 day. Okay, so this was startling for me. So now let's go to the third question and see. There are these recent past like Earth Day, where we are motivated to keep all our lights and fans and everything off for 1 day. So cities are often asked to switch off all appliances and lights for 1 day. So let's see how much coal people we will not burn if our city did not use light bulbs for 1 day. Okay, so we're going to assume that population of, let's say I'm in Hyderabad, so I'm going to use the example of Hyderabad here. Population of Hyderabad is like up to 120 lakh people, and we have around 3 members per house, and 20% of the houses in Hyderabad, let's say, do not have any electricity, and the houses that do have electricity, let's say they use 4 bulbs of 100 watts for 6 hours a day. Okay, so basically, let's say in Hyderabad there are 120 lakh people and they all use 4 bulbs for 6 hours a day. And if they turn it off, all these people just turn it off for 1 day, how much coal do we save? Okay, so we have 120 lakh people, right, guys? That means we said 3 members per house. So we have 20 lakh people, so 40 lakh houses. Am I right? Yes. And 20% of them do not have electricity. So we have 32 lakh houses with electricity, right? We have 32 lakh houses with electricity, and each house is turning off 4 bulbs of 100 watt for 6 hours a day. So 4 bulbs of 6 hours, it's like basically they are running a 100-watt bulb for a whole day, right? Like let's say they run 1 bulb, they run it all together, but basically it comes to using a 100-watt bulb for 24 hours. And we know how much kg of coal we use to power a 100-watt bulb for 24 hours. How much was it? Around 1 kg, right? So basically, each house saves 1 kg of coal when they turn off all their lights for 1 day. And we have 32 lakh such houses. So basically, if we have an event like Earth Day, and all of the people in Hyderabad just turn their lights and fans off, 32 lakh kg of coal is not burned. This is from 1 day and just from turning off the light bulbs. Okay, and we know that light bulbs are 100 watt, and I told you, an AC is 5,000 watt, a TV is 400 watt. So imagine if you have a 400-watt TV and you're not watching it and you run it for 2 hours. That's 1 kg of coal that was burned to keep your TV just running without anybody seeing it. And this is just one person. And you can see in a city like Hyderabad, like how many people are there? 120. There are literally like 32 lakh houses, and each house, even if for 1 day, like they turn off their lights for 1 day, we save 32 lakh kg of coal. And we already saw all the effects of how much CO2 is produced by coal, how much pollution is produced by coal. Is it really surprising that we are in so much trouble? Because we use so much energy. It's not that our energy is not important. Like having electricity lights are important. Like, they allow us to study, they allow us to do our work, they allow us to deliver our lives well. But it's also important to know how much energy what are we doing to produce that energy, and how do we mitigate all the negative effects. So guys, I hope you like this. This thing, I can also send you this calculation on email, but it's very simple, guys. Basically, you just convert your watt into joules per second, and you know how much energy is used. And it's 1 kg coal, you know how much energy it produces. So typically, a 100-watt appliance for 1 day is 1 kg of coal. So if it's a 500 watt, you can multiply it by 5. If you're using it for less time than 1 day, you can divide that, and you can easily come down to it. When I did my calculation for myself, I came to that easily, like 50 kgs of coal I burn every day, from running my laptop, for keeping my food refrigerated. Like I'm just one person. I thought, I'm a simple person. I don't have many needs. and I realized that I'm burning 50 kg of coal every day. So this really shows the importance of why we need to keep our fans and lights switched off, why we should use things, and we should also support policies that make us move towards more healthy ways of producing our energy. So we need to look at both sides of the equation. We also need to look at the equation of reducing how much energy we use, because we have to be aware of how it is being produced, and also move towards sustainable ways of producing this energy so that we don't end up with a dirty and completely overheated planet. So as guys, I'll just go over the third question again. If you use for one day, we have 120 lakh people, 3 members per house. That means that there are 40 lakh houses. Let's say 30 lakh houses with electricity. And if each of these houses for one day they don't use 4 bulbs, we don't burn 32 lakh kg of coal. And I think on this note, we'll get back to the session now that we understood how much coal each of us is using every day. We'll get back to the session. I hope you found it interesting, guys. Back to you guys.
Yeah. So thank you, Saket. Yeah, so I was saying thank you to Saket, and it is a happy realization day for all of us that we burn a lot of coal living our lives every day. So that brings me to our fourth question for today, which is like, is it like kind of a bleak scene out there? Like we are all going to sit and burn 50 to 100 kgs every day and finish off
Gayatri's connection.
Natural gas.
Yeah, I'm sorry, Gayatri, I'm not able to. You're breaking up. So
Hello.
Yeah. So basically, you're asking, do we have to resign ourselves to just admitting that we are only using non-renewables and accepting that this is going to be a way of life, or is there something different can we do?
Hello.
You can't hear me? Have I gone off?
Can you hear her, Gayatri?
Saket, can you
no,
hear me?
I can't. Yeah, I can hear you as well, Deepa, now. Sorry.
Okay. So, so I believe the question is that what can we think about of our future? How can we improve our future from the current status, right? So where is the world going to be headed? Or are we going to always have pollution in our life and climate change in our life? And the fact is that obviously not. We want to not have that. We want to be able to do a better job for our future, for our children, for the future generations to come. So question is, what can we do? So obviously this is about moving away from non-renewable resources to something called renewable sources of energy. So what are renewable sources of energy? And I was looking at the YouTube chat, and people have already come up with fantastic ideas. And I would sort of like to just say that, yes, there are very nice, very useful, very important renewable sources of energy. And I will try and highlight all the pros and cons as much as I can think of each one, because nothing in life is perfect, okay? So one is the simplest one, I shouldn't say the simplest one, but one of the most important ones is something called wind energy. Okay, there's a lot of wind on our planet. Certain areas, certain parts of our country have a lot of wind. And so what we can do are we can create what are called these wind farms associated. So these wind farms are nothing but where you have these windmills, these gigantic windmills. When wind blows, the paddles of the windmill turn, and they convert the kinetic energy of the wind again into a mechanical energy that drives a turbine engine that is inside, and that turbine engine converts it into electricity. Okay, this electricity then gets stored. In this little image I'm trying to show you, these are batteries here. You see the little human beings here in white, and this is like a large energy storage facility that the electricity that is generated from these windmills gets stored here. So it's a fantastic idea, and this is electricity that we can use. Okay. But so these are pros. You are not burning any carbon dioxide. No carbon is being released. It's completely wind energy getting converted into electricity. The few problems associated with it, not every place in the world has a lot of wind. So you need to find places that have wind. Then you need this needs large amount of space. Okay, a coal power plant has a very small footprint, means uska size bahut chota hai. The size of the power plant is maybe 1 acre or 2 acres or 10 acres. The wind farms, the wind energy farms are 10 times bigger. Okay, they need 10 times more space to generate the same amount of electricity as a coal thermal plant. So you need large, vast areas, plus you need to couple the wind farm with energy storage. So you need these large storage facilities. Think of them as very big batteries, very, very big batteries, okay, that can store the electricity. Because wind is not blowing 24 hours a day, it only blows at certain times, and you need to do this. There's another little small drawback. It is that actually a lot of birds are killed by these windmills. It may not sound like a big problem, but conservationists, wildlife conservationists have a huge problem because it creates, when these windmills are turning very fast, birds do not see it and they fly right into the windmills. It actually is a big problem because governments cannot put these wind farms everywhere they want because there's a lot of pushback from the environmentalist or the conservationist. Okay, so these are the pros and cons. And there's a small little thing, these wind turbines create a lot of noise. So if you live near one of these windmill farms, you will find that when the wind is blowing, these turbine engines create a lot of noise and you can hear it, and people don't like living near these things. Okay, small, but these are side effects of the main important aspect that you will circumvent climate change if you try and install these things, which is a good thing, right? So that is one aspect. Here's another type of renewable energy, and this one I'm sure all of you know about, and these are solar cells. Solar cells are fantastic. Again, solar cells, what do? They take sun's energy that is coming and they convert sun's thermal energy into electricity directly. There is no turbine engine here and there's nothing. These are just flat panels. Again, they need a large amount of space to generate the same amount of electricity. They need about 10 times more space than a coal thermal power plant to generate the same amount of electricity. The other thing is these solar panels do not live forever. They have a lifespan of about 20 years. So every 20 years you have to replace them. Their efficiency decreases year on year. Okay, so we need to make stable solar panels. You cannot put these solar panels next to, let's say, a cricket playground. Balls hitting it will destroy it. You need to find places where they are protected. If you have lots of hail or trees falling or things like that, they will destroy these solar cells. So the location has to be picked carefully. They need large space. And again, this is energy capture. It's converting sun's energy into electricity when the sun is shining, but at the same time, you need to store the energy. So you need to again have a battery setup, energy storage setup, just like the wind farm, to basically store the energy when the sun is shining. Because funnily enough, we don't use that much energy during the day. We use more energy at night. So we should capture electricity during the day, store it, and then use it at night when the sun is not shining. So these two things need to be done. Okay, so these are two of the more popular ones. And finally, I want to talk about one third very interesting one, which many students may not have heard of. Okay, maybe they have, but I will just highlight it's a molecule now. So we're not using wind energy, we're not using sun's energy, but now we're going to use something called chemical energy. That is what coal is. Coal is a type of chemical energy that releases heat and it gives us electricity. So can we find another molecule that can give us the same amount of heat, but that does not release carbon dioxide? and that molecule is a hydrogen molecule. Hydrogen molecule in this case is H2, okay? What I've shown you here. These are various ways of depicting it. I don't want to go into too much chemistry, but I want to highlight from this little table. What I want you to see is basically the left side are various words that you might have heard of. These are various kinds of chemical sources of energy: diesel, jet fuel, gasoline, and so forth. Okay, and coal is here, as you can see, wood is here, TNT is your explosive, and batteries. On the extreme right side of the table, I want you to see which is how much energy is stored per kilogram of the material. Okay, so as you can see, why do we use diesel and gasoline? Because they have higher energy per kilogram as opposed to batteries, for example, or TNT or wood. Wood is not as good as coal is, right? Coal is, intuitively, you know this, cooking food on coal, on a chula, is more effective as opposed to cooking food on a little wood fire. Okay, because coal will give you more energy and you can use a pressure cooker on coal. It's harder to use a pressure cooker on wood. Okay, not that it's not possible, but it's less energy. Now I want to show you what happens in a hydrogen molecule. How much energy is stored per kilogram inside this particular fuel. And as you can see, it's substantially larger. Okay, it's 142 megajoules per kilogram of energy stored in that hydrogen bond. And that is the beauty of this molecule, which is not only is it very energy intensive, it will give us lots of energy per kilogram, so we don't have to use a lot of it. But the best part is that we will not release CO2. Okay, that it will not cause global warming, because unlike carbon fuels, when we burn it, like this equation gives you CO2, but when we burn hydrogen gas in the same oxygen, we only get water. But we get water, which is a fantastic molecule to have, okay, and we also get lots of energy from which we can generate electricity and do lots of things. Okay, so hydrogen is the molecule, is called a renewable source of energy for us, and we want to use it in what is called a fuel cell. So Gayatri, you want to ask me some things, or shall I continue? Because this is, for example.
Yeah, so I wanted to ask, I wanted to look at these three energy sources. Like you were saying, there is wind, there is solar, and there is hydrogen that gives just water. And so from what I understood from your discussion is that definitely these sources of energy have a much smaller carbon footprint in terms of the way.
Sorry, smaller. Yeah. Agreed.
Yeah, so we do not burn any coal in this process, but probably for the installation of, say, the windmill, we might be using a little bit of coal, and also, like you said, the solar panels might be wasteful later once their capacity is used up. But other than that, I can't really see if it's not good, or if not, it's much better than the sources of energy that we currently use. But it looks like it has a lot of science to do out there, or we need to improve the technology a lot in this research area to develop all these renewable resources as sources of energy that can feed, like you were showing in your graphs, very populous countries like India. So is there any I'm sure we have a lot of aspiring chemists or physicists or maybe engineers in our audience. So I want you to I wanted to ask you if you can tell in simple words what technology can be developed to make this better, energy efficient, and also we can design better things to store all these energy so that we can use it for longer term. Like if there is a better material we can use instead of the solar panel to capture sun's energy or something like that. So these are a few ideas that I got, but I don't know what the students think. So do you have anything to say on that front?
Okay. So basically, I will tell you about what is the direction researchers are trying to pursue in terms of trying to fight climate change. How can we reduce CO2 on our planet? Okay, so there are various ways of reducing CO2 on our planet. One way is obviously, yes, we build more wind farms, but only the countries that have a lot of wind. And it turns out places like Europe are very good with that. So Europe builds, and they don't use land, they build them offshore, they build them on the ocean. The wind farms are built on ocean. So you need better materials that can withstand, you know, mechanical waves sort of coming and crashing against the windmill. So there's a lot of engineering research that goes into that. You need to build better and better turbines that they can have more efficiency. You see, when the windmill is turning, it needs to basically more efficiently turn the turbine. You should not have loss according to heat. So material research is very big in terms of wind turbines. By the same token, in solar cells, we want to absorb sun's energy. We want to build cheaper solar cells. The reason solar cells have been around for a long time, let me just explain. They've been around since 1940s. Okay, solar cells started getting invented in 1940 and we are now in 2020. But you and I still do not have a solar cell on top of our house. Why is that? It's not that the science doesn't exist and people are manufacturing it and you can buy these solar cells. But like I said, a couple of things. One is that when you invest in the solar cell, it's not cheap. It costs money. So in principle, only rich people are doing it right now. Why does it cost money? Because the chemicals that go into making the solar cell are not abundant chemicals. These are exotic elements that are expensive. And because of that, the solar cell is expensive. In addition, when you buy the solar cell, you need to devote a room in your house, the size of your bathroom, for your battery to store the energy. How many of you have an extra bathroom that no one uses? Okay, in India, we do not have luxury of space that we can devote a space around about 100 square feet or so that we can devote to energy storage. Matlab, where you will put your batteries. So during this day, the solar cell will capture sunlight and store the energy in that battery pack. And at night, you will use that electricity to, you know, cook and watch TV and put on your light bulbs. So the one is that we need to make cheaper solar cells. We need to find ways of storing that energy in a much more compact way. We need to make better batteries that are smaller in size and more efficient. And this is all about material that kind of can be used. At the same time, we want to make them last longer. 20 years is not a good enough life cycle for a solar cell. Why should we have to change a solar cell every 20 years? You invest so much. So the idea is that can we make them more robust, better at it? Wouldn't it be nice, for example, if and many of us do not have a rooftop on which to put a solar cell. So instead, why not make the windows out of, so, you know, a lot of us don't like sunlight during the day. We put curtains, correct? You know, we don't want sun coming in. So we put curtains. Instead, why not make certain kinds of solar cell that basically capture the sunlight during the day? And so the solar cell is, your window is made up of the solar cell, okay? And then at night, it becomes transparent. So during the day, it's opaque, it captures the sunlight and it keeps you nice and cool inside your house. So the window does dual function. You don't have to buy curtains or blinds. And at night, that same solar cell becomes transparent. So you are allowed, you know, you want to see at night, because sun is not shining, so the solar cell is not in use anyway. Okay, so these are inventive ideas of how people can make different guys. Why should solar cells be inflexible? Right now, they're made of inorganic components and they look like slabs. You can't bend them or do anything with them. Why can't we make a solar cell that is like a newspaper, that you can fold it and put it in your bag when you want and open it when you need it? Okay, and that is robust. Therefore, you can use it wherever you want. When you're out in a picnic, you can open up your solar cell and watch TV while you're sitting in your park. Okay, so these are all various ideas of how we can think about energy in a different way. By the same token, like I mentioned, this hydrogen gas. How can we find better hydrogen gas? Like I'm showing you this bus runs on hydrogen gas. But the reason you and I are not driving a car or a scooter on hydrogen gas is simply because there's not enough hydrogen gas in the world right now to meet our requirement. Okay, there is no lake under Saudi Arabia full of hydrogen gas. Like, that we can just say, okay, hydrogen gas will come out for us. We have to make it. So this is where we do research of how we can make hydrogen gas more efficiently from water.
So Deepa, I think we should have this discussion more, like how can you innovate different things to capture more energy. I would like to save it to the next section of our discussion. So before that, I want you to give like a quick recap as to, I've heard of other forms of energy as well, like which are renewable, hydroelectric is one, like where you build dams and all of that, and geothermal is also, nuclear of course, and geothermal is also something that I read in one of my chapters from school. So what are these? Like, I know that wind and solar are fantastic, but how do you make electricity from hydro powered dams, or from geothermal, or like you said, nuclear, before we break for a game?
Okay, so I'll be very quick. So I did not mention these techniques because there's some issues with respect to pollution when it comes to these three techniques. Okay, so I will quickly talk about hydroelectric. Hydroelectric is nothing but when you have water at a higher position and you drop it down. Okay, so it has higher kinetic energy and you drop it down like a waterfall, and it will basically convert that energy into potential energy. But what we do is, while it's dropping down, so it has higher kinetic energy, it again drives a turbine engine at the bottom, and it captures that energy. That kinetic energy is captured in a, just like in a wind farm. Just all of this is just very simple, capturing kinetic energy, converting it into mechanical energy that gets converted into electricity. The problem with a hydroelectric is you need water at two different heights, okay? And you need to store the water. So you need to create basically what is called a dam. And you need and you also need space at the bottom when you're dropping the water off. So what ends up happening is lots of land is used for this, and people are displaced from their villages because people live in valleys normally. You can put water at a higher level, but people live in valleys and you need to get them displaced out of there, and you need to build this large infrastructure where a turbine engine is there and you're capturing the waterfall's energy. So there are conservationists don't like this because wildlife is displaced. You know, people, forests are sort of flattened out, or agriculture land is used to create these hydroelectric dams. Okay, these are man-made devices, but yes, there's no carbon dioxide that's released. Absolutely. So in that respect, it's a good thing, but there are drawbacks. With nuclear energy, what is nuclear energy? And India invests quite a bit on nuclear energy. Nuclear energy has to do with what is called nuclear fission. Means we take a atom and we break it apart. We take the nucleus and we break it apart. When we break it apart, we release a lot of energy. We break it up, think of it as dividing it in two. The nucleus of an atom, we're dividing it into two, and we're releasing a lot of energy, which is fantastic. And this energy is huge amounts. You know what the atomic bomb is made of. That is uncontrolled nuclear energy. In a nuclear reactor here in India, we make these nuclear reactors. It's controlled energy. We try and do the nuclear explosion in a controlled way. Problem with this is there is a lot of radioactivity associated with it. Plus the atom you're splitting is an atom called uranium. And we don't have a lot of uranium in this country. So it's limited in the amount of uranium you can use. It gives off plutonium. You can do a second reaction. You can break off plutonium as well. Fine. But the point is, at the end of it, you get radioactive waste. You don't get carbon dioxide, but you get radioactive waste out of nuclear using that reaction, the waste. You get energy and this radioactive material. Now you have to store it, and that becomes an issue. So people bury it underground, many kilometers or meters underground, but it's not a perfect answer. Plus there's an issue, if you have by mistake a safety aspect, an explosion that you don't want. So there's lots of side effects that you have to really control your nuclear technology really well, because no one wants to see a nuclear disaster happening, because it causes cancer. It's a main, a side effect of any nuclear explosion is people in the vicinity get cancer, which is not a good thing. And the third thing you mentioned was geothermal.
Yeah.
So geothermal is nothing but where you have, again, lots of heat buried underground. Heat matlab steam, and this steam is let off. Steam has pressure, steam has heat, steam has temperature associated, and we sort of create a small nozzle. We bury, for lack of a better way of doing this, we put a little nozzle down into the ground, and the steam gets released. Okay, as it gets released, it drives a turbine engine and generates electricity. Okay, so geothermal is we're using our planet's inherent heat and steam, which is kept under high pressure, to drive a turbine engine to convert it into mechanical and electrical energy. Is that clear, Gayatri?
Yeah, yeah. So I think we are good to go for the first game of this session, after which I've already jotted down a lot of interesting questions to discuss with you. So I hope our audience stays tuned for that. And over to Saket for the game session.
I've lost audio. Is everybody okay?
Oh, okay. Now can you hear me?
Yeah.
Oh, sorry, I was muted. My mistake. Okay, guys, I was saying, yeah. So I was saying that. So we're gonna play this game here, guys. So basically, in this, we are going to go through regions and try to use some renewable sources of energy there to save energy, right? So we talked about all the different kinds of renewable sources. So let's start somewhere. Let's start maybe, okay, let's start in, let's not start in India, because, I want to save it for later. Okay, let's start in the US, okay? Oh, this is the Canada. So basically, we have five sources of energy here, guys. We have dams, we have tidal energy, in which the tide goes up and down, so that generates some force and creates energy. We have wind energy, where wind rotates the fan, which in turn rotates the turbine to create energy. We have solar cells, and we have geothermal energy, where the pressure from steam rising from the ground produces energy. And we have hydroelectric energy, where running water runs a turbine and produces electricity. Guys, so the environment also depends. So now let's try this, and we can use only 3 maximum out of these. So yeah, let's see. In this place, it's too cold, so obviously it's not going to be solar. There are 2 spots in the water, so I guess that's going to be tidal, right? So you can see that, the tide is going to go up and down and produce, and maybe the others are going to be wind, right? Let's see. Yes, I think we can win it this way. Yes. So in Canada, we have used tidal power. So, in this game, guys, do check it out. After every region that you go through, it also gives a nice animation of how tidal energy works. The tide goes up and down. So it's a very interesting game. So in tidal energy, basically the tide goes up and down. The tide, right? The sea levels go up, they come inside and then they go out. So this difference is used to run a turbine. Right, like basically the tide goes up, the water is stored, and then that water is let to run down to turn the turbine. Okay, let's go to the next region, guys, quickly. Let's go to the US now. Okay, now this is a little hard, I think. Okay, let's see. Maybe geothermal? No. geothermal here. It looks pretty sunny, yeah. So you guys, this in the middle latitudes near the equator, there are more date. You know that near the equator we have larger time of day, we have larger amount of sunlight, and towards the poles we get less sunlight. So solar energy is something that's more useful nearer the equator for tropical countries, and probably wind energy, yeah, right? So I think we saved the US. So basically here we have this animation about how the solar energy works. I really recommend you guys check it out. We'll run through all the different games. So tidal energy, what solar energy is basically for light is used to run a chemical reaction, which gets converted to electricity. Let's go to India. Let's see what they suggest for India. So let's see. So there is something on water here. Okay. There's something on water here. So I guess that's going to be a hydroelectric dam. All right. There is maybe wind, because India, wind is not so good here. Oh yeah, India has a lot of sunlight, so I'm sure solar should work. Yes, I can. I think I can put in 3 solar panels here, 1 dam over here, and maybe a geothermal plant. No. Maybe just a wind only. Yeah. So in this we talk about hydroelectric power. Basically, running water runs a turbine. And let's go and just finish up the rest of the regions. Let's go to Europe. So guys, what do you think about Europe? What do you think you can do here? I think geothermal energy is used a lot in Europe because there's a source of a lot of natural springs. So geothermal energy, where steam rising from the ground, is used to, there's a lot of steam that is trapped under the ground because of under pressure. If you open up a vent, it comes pouring out, and that can be used to run a turbine. And I think Europe is pretty okay. Solar is not so efficient. Maybe wind, yeah. So wind energy as well. So then we got to success in France. Guys, do check out this game. It's really informative. It gives a lot of information on how these different things work. Okay, now this looks cool. There's a lot of water. So I'm assuming that, see, in the water, it's going to be tidal, because and we have a running water here, so we're going to put up a hydroelectric dam there, and maybe another dam over here. Yes, and yeah, so hydroelectric power. So we have an animation about how hydroelectric power works. Quickly running through the rest of the 2 regions, guys, because I really want to win this game. Oh, now we are in Japan, and you can see all the buildings. Now, Japan is one of the most highly industrialized countries in the world, so it's pretty representative of how Japan looks. And look at that, there are 3, rooftops. So I'm sure the solar panels go on the rooftops. Yes, and land of the rising sun, as they say. So we have 3 solar panels, and maybe we can just pop in some wind farms. Yeah. Yes, wind and solar are. I prefer them to hydroelectric, so I'm using a lot of them. And one more region. One region. Oh, New Zealand. People always forget about New Zealand on the map. Guys, do you know where New Zealand is on the map? It's to the east of Australia. People in New Zealand always complain that when people make maps, they don't show New Zealand. But anyway, we'll go on to New Zealand. And what do we use in New Zealand? I don't think solar is going to be so good. Yeah, you see only 3 kilowatt per hour, because New Zealand is such a low altitude, right? It doesn't get much sunlight. So solar is definitely not the thing. I think wind should be okay. So we're going to put 3 wind over here, and the water one is easy. We'll put tidal, and maybe 1 geothermal plant. Oh yes. So guys, basically this game is like a very small fun game, just to let you know how the different things work. There's hydroelectric dams, there's solar panels, there's geothermal. So please go through it, and do look at the videos at the end of every segment. It really in a very nice way explains how all these renewable sources lead to electricity, how it is used to lead to electricity. And like the discussion between Deepa and Gayatri, these are all things that we need to use because for 2 reasons. Like coal is very polluting, we get a lot of pollution, both coal, oil, and very polluting. We get a lot of pollution and produces a lot of carbon dioxide. So while we work on how to mitigate the climate change, etc., we need to reduce our consumption of coal and move to renewable resources, while also understanding what are all the costs and damages that the renewable resources also cause. Like she was saying, building dams causes a lot of damage to ecosystems. And one thing about the solar panels that you didn't mention was, I saw research that, to clean the solar panels, how much water is used. Millions of tons of water are used to clean the solar panels. So we really need to move forward. All of us need to pitch in together. So there are scientists like Deepa and many others who are working hard to create the technology and also inspire people to use. So we have to support them while also understanding our own footprint and reduce all unnecessary consumption. And just, I think simple steps would very much go a long way towards protecting the environment and also reducing all of our footprint while transitioning to a greener and more sustainable way of living. With this, I'll get back to Gayatri and Deepa. I think we'll be wrapping up the session soon, but there's one more quiz left, guys, and then we'll take your questions as well. Yeah, so I'm heading it back to Gayatri.
Hey, so we're back, Deepa. That was an interesting game, I felt. One thing that I was thinking, I was going through the comment section in the meantime. I saw a lot of interesting questions, and also students were telling they have some ideas about making certain battery devices and things like that. So I was thinking that we have so many ideas as a race, as a human race. So what I was thinking is people had also talked about afforestation, like we need trees because trees can take in carbon dioxide. And so this brought me to a question, like if that can take in carbon dioxide and they also produce energy, right? Like glucose is their fuel to sustain. So is there a way that you can take CO2 like plants do, like something like biomimicry as they call it, like seeing nature and doing something? So are there ways scientists doing such things in our country or even abroad?
Absolutely. This is one of what is called the holy grails of research. The idea is to mimic photosynthesis. I'm sure all of you would have heard the word. You may not understand how it works, but photosynthesis is a fantastic chemical reaction that plants do. The only thing is they do it a little slowly. Okay? The reason I say slowly is think about how long it takes. What do plants do? They take CO2 and they make glucose. All right. And I want you to just intuitively appreciate this. There's lots of CO2 in the room you're sitting right now. Okay. You're breathing out CO2. Do you see glucose falling out of the sky? No. All right. Converting CO2 to glucose is an uphill reaction. It requires energy. All right. And because it requires energy, I'll try and sort of show you one second. I'll just show you by what I mean by that is that it's an uphill reaction, and because it's an uphill reaction, it requires energy. So plants use energy. Where do they use the energy from? They use it from the sun. Sorry, just one second. This is the reaction I want to show you. Okay, all of you are familiar with this. Plants will only convert CO2 to glucose when the sun is shining. So plants use sun's energy and they use a catalyst, which is part of chlorophyll. That is why everything looks green, okay? Because it's a very nice catalyst. It's a green colored compound that takes sunlight and using the energy of that sunlight drives this reaction of carbon dioxide to form glucose, okay? And that is what we call photosynthesis. So we as scientists have been wanting to do this in a beaker for a very long time. We cannot do this to date, okay? We cannot mimic photosynthesis. The other thing is, in principle, I actually don't want to make glucose. I want to manipulate. I want to change photosynthesis, that I still want to take carbon dioxide and water, but instead of making glucose, how about I make ethanol? Ethanol is a much nice, or I directly make gasoline. Okay, wouldn't it be nice? Because I don't use glucose to run my car. I use gasoline. I need gasoline more than I need glucose. So wouldn't it be nice if I can convert CO2 directly into gasoline? So we want to understand photosynthesis, but we want to tweak it, and so that we make a material that is more useful to us. And that is what research is all about, because there's a lot of science is hidden under this green arrow. Nature is very complicated. We cannot even understand photosynthesis very, very clearly. We're trying, everyone is trying, and they, people, big papers keep coming out every year, but we're getting closer and closer, but that is where research is. So it's very interesting that you can circumvent climate change. You can circumvent pollution in different ways. One is that you don't release CO2 at all. And another is, if you do release CO2, can you do something else with it? Other directions that I will just highlight, some ideas for the students to think about. How about we try and, rather than plugging everything into the electrical socket, how about we put everything under sunlight to recharge? For example, if your mobile phone is running low on charge, rather than plugging it into your electrical socket to charge your battery, how about if your battery gets charged directly with sunlight? So you just put it out in the sunlight, you're driving in your car, you stick your hand out with the phone, and the phone gets charged up. Wouldn't that be interesting idea? So you're circumventing electricity completely, and you're grabbing sun's energy. And these ideas are important about sunlight because we live and work in India. India has a lot of sunlight. So a lot of research is based on sun as opposed to wind. Wind are in very small, secluded areas of India. Europe has much more rampant wind areas, so they spend more research on wind energy. A country like India needs to invest, and is doing, more on sun's energy, or capturing sun's energy and doing interesting things with it. There's so much of it.
Yeah. So this is this is really interesting. Like I
Oops.
Trying to think like hello.
Sorry, Gayatri, I lost you there for a minute. Can you just repeat your question if there was one?
Yeah. So I was asking. I was just very surprised that I asked you something, and you had an answer in the form of photocatalysis. So I'm just interested in another thing right now. Okay, I want to ask you, if I don't know if it's a stupid question, but just trying to think like a scientist. Can we make coal again? Like, is it? They say that it is a non-renewable resource, but since scientists have an answer for most things, is there something called synthetic coal, something like that acts like a coal, and we can probably use it to create energy?
As far as I know, no one is trying to make synthetic coal, to be honest with you, because we need coal for electricity. So people are trying to find ways of just generating electricity without forming carbon dioxide. Rather than coal, what we need is fuel for transportation. You see, cars and buses to move people around. We need lots of energy for transportation. So for that respect, people are working on direct forming what is called biofuel. Okay, so biodiesel, bioethanol. So what does that mean? These biofuels directly is, can plants make this for us? So like this reaction is showing you glucose, but can plant give us ethanol? Can plant give us faster ways of forming diesel? So can we do genetic engineering of how the enzymes work inside various species of plants that can give us high concentration of those kinds of molecules? So there's a lot of research going into that. But in terms of forming synthetic or bio coal, as it were, I am not familiar right now. And I don't think there needs to be, because I think we can do better. I mean, we spend our intelligence and our resources finding, something, because eventually when we make coal, we have to use CO2. Then we'll have to again come back to this question, can we capture that CO2? Okay. So coal
Yeah,
releases
I get it.
more CO2 than many of the other carbon-based molecules.
Hmm. So before we end the session to break for question, should we have another quiz, the second quiz right now? So Sakit, are we ready for the next quiz?
Yeah. Thank you, Gayatri. Thanks, Gayatri. Is Somdata, are you there? Hello, Somdata. Okay, all right. So let's give them just a minute, guys. After this quiz, I hope that at least a few of you will answer. After this, we'll have a small question answer session where all your questions will be addressed. All the questions that have been answered, that'd be really interesting. So guys, quickly fill up the answers for this quiz. I'll also go through the questions. Deepa, you might find, I hope you saw the questions for the last one. Let's see this one.
I
And
thought that game was fascinating. It was interesting, that they didn't put nuclear energy because in reality
yes,
in the world, India is perhaps
yes,
leading between India and France. We are the
yes,
very few
yes,
countries in the world that are thinking of nuclear technology. The rest of the world has
yes.
given up on it.
Yes, yes. Which I find it, I don't know. Um, yeah, it's a very double-edged thing, nuclear technology. I feel like I can find arguments, very convincing arguments on both sides. On one hand, there's so much energy that gets produced. Like it's just ridiculous the amount of energy that the nuclear bomb, the nuclear, the nuclear force is something that's very much crying to be tapped. But on the other hand, there is this new radioactive waste which we really don't have any long-term solution to. So I don't know, where do you stand on the debate?
You see, I think every country needs to look at its problems separately. And for India, because of our population,
Yeah,
I think it's very important that we invest in all these forms of energy, and we invest it rampantly.
yeah,
The problem is the government is a little, you see, on one hand, the government, it's politics. They don't want to do load shedding. No one likes not having electricity. So even as to 2 years ago, they were still building more coal power plants.
yeah.
Okay. It's not like people are not, the government is not investing in coal. It still is investing in coal. It's trying to invest, but the investment in coal is very cheap. You need to put in only a little bit of money because the science is so old that you generate electricity fatafat. And climate change is a problem that the future party in power will have to deal with, not the current party. It's almost that mentality. Whereas with renewables, the investment you have to put in now, and it's a lot of investment for hope that it will yield dividends later. It still is an expensive direction, renewables.
Yes, I think what's her name? Greta Thunberg. She was leading this Fridays for Change movement. But basically, the young people need to be really aware. Like the old people are swindling them here. Just like you're talking about, not just about politics. It's even generations. The kind of energy we use and the amount of climate change we cause. We talked about last session that a 3-degree rise in temperature wreaks such havoc on ecosystems that all our food security and energy security comes hugely into question. And the current
Saket,
trajectory
you
is that
see,
we're
in
getting there.
India, there's another problem, and I don't want to sort of not understand this, which is we have a huge problem where people, for example, need education. Are you going to tell a poor person, please don't switch on the light bulb at night
Exactly.
and not study? I mean, they need energy to improve their life. Okay,
Mhm.
the student needs to, the poor child and they need irrigation for their farm. You cannot ask them to think about climate change when they're just thinking of survival and improving their bearing in life. So, it's sort of, Greta Thunberg is fantastic, but I think the problems of the richer countries and the way they have to deal with climate change, they have a luxury that India does not have.
Yeah, I think that's what we are stuck in this very spot where, we don't have the luxury of being able to just just use all these, because the dangers are immediate. Like climate change has become a very serious problem. The floods, there are already so much floods. There's the greening of the Tar, which is a big issue. There's so many floods in Kerala, Orissa. Like the impacts are already now, and we are struggling with a burgeoning population with so much developmental needs. I think like you said, it's very important that for at least the citizens and everybody to at least support policy that funds science and technology regarding to this, such that we, and such that we, like you said, our problems we have to deal with in our own way, and we have to look at the pros and cons and come to a decision. I don't think any source of energy or anything is going to be perfect. So in that sense, I think it's very important that we keep that in mind. And even increasing water levels is like a crazy threat to a place like India.
It's about balancing, and it takes awareness, and that is why I was so impressed, and I'm very happy to participate in these events, because it's just raising awareness. And I think the first step is people appreciating the problem and realizing to solve these problems is not a simple wave of the hand, and money will not alone do it. It's commitment from everybody involved. But it's also realizing, look, we cannot do it at the risk of keeping our society down. We have to make sure that we take everybody with us. And think of it, if we have a fantastic source of renewable energy, imagine if you can generate hydrogen gas in your backyard with a simple catalyst and a beaker of water and sunlight. You will have all the electricity you need. You will never have to fill an electricity bill in your life. Okay? So the city does not have to build coal power plants.
Just like we grow our own vegetables, just create your own energy.
Exactly. You're generating your own electricity when you want it. All you need is water and sunlight. So we're working on these molecules that can do that. And if we can generate our own hydrogen gas, then you have the fuel for your transportation, you have fuel to generate electricity, and it's all pollution free. Therefore, you don't feel guilty if you have 1 car, 2 cars, 3 cars, you can have all of that. Well, you can have electricity 24 hours a day and you're not harming the planet. But it needs investment, and it needs people to have that vision and say, we have to get there.
While the problems also grow exponentially, I think the solutions also come a little exponentially, because we have so many people working on it, and we have platforms like the internet where people can collaborate. We see that even though during lockdown, there are so many scientists who have come together to do so many things. So I personally am very hopeful that all the scientific community and the people in education we can all pull together and tide over this crisis in certain sense. So on that slightly positive note, let's go on to the quiz. I hope we got some answers for this, Somdata, a few, because I know people are having lunch and they're having school and things. So are you there, Somdata?
Yes, let's discuss this.
Shall I go ahead to do the questions?
Yeah.
Okay. So this quiz, guys, this is covering more of so which of the following environmental problems is not related to combustion of fossil fuels, right? So if you went through this talk, you should know this. So I'll just explain the terms as well. Smog is basically caused by carbon particles out of pollution suspended in the air. If you remember, Deepa showed a slide of what Tokyo looked like with China, Beijing looked like with smog and without smog. It was a drastic difference. So definitely smog is caused by burning of fossil fuels. Acid rain is something that is also caused by burning of fossil fuels, because that condenses and destroys crops. The greenhouse effect, of course, is an effect of burning of fossil fuels. What is not caused related to consumption of fossil fuels is nuclear radiation. And nuclear radiation is also an environmental problem, because the waste that gets generated from nuclear power plants, they are very long-lived and they generate a lot of radioactivity, which is very harmful for us. They causes mutations and they need to be kept away. So the answer for the first one is nuclear radiation. Smog, acid rain, and greenhouse effect are all environmental problems related to combustion of fossil fuels. Anybody you want to tell us, Somdata, whether people got it right?
Yeah, 77% of them have gotten this right.
Okay, so I think
there were still a few people who thought that greenhouse effect is not because of combustion of fossil fuel.
Oh, maybe I think that is due to the people not just realizing that it's not.
Question,
Yeah, they just went to which of the following problems is related,
Right.
I make the same mistake in all the multiple choice exams.
The greenhouse, people always think it's an ozone issue, all right? But the depletion of ozone layer is directly related to CO2. So
yes.
that is the main thing.
That is the main thing. Yeah, people also think that greenhouse is more related to the ozone layer. There's actually the buildup of CO2 and heat that causes it as well. That's true. The second question is, you have coal, petroleum, and there were a lot of comments talking about CNG, using CNG. CNG, natural gas, is also a fossil fuel, guys. A fossil fuel is something that, we dig up from the ground. It's not something that you can make. It's being made over a very long period of time, millions of years, and we use it, and we don't have millions of years to make it again. So why are these called fossil fuels, right? Why are these? The options are they're burned to release energy and they can cause air pollution. Is that why it's called a fossil fuel? They are non-renewable and will run out. They are mixed with fossils to provide energy, or they were formed from the buried remains of plants and animals that lived hundreds of millions of years ago. So, guys, fossil fuels are burned to release energy and they do cause air pollution, but that's not why they are called fossil fuels. They are non-renewable and will run out. That is true. They are not mixed with fossils. The answer is they were formed from the buried remains of plants and tiny animals. So basically what happens, guys, you have all these forests. At some point of time, they'll be in the ground, right? And layers of soil will come over them. Over millions of years, what happens is this high temperature and pressure, like they say, coal gets converted to diamond over millions of years. It's the same way. All this organic matter gets converted into coal. So if you go back and look at Wikipedia or something, guys, you'll come across something called this Carboniferous era in the geological period, where there were huge, vast amounts of plants. So what we are using now is basically the remains of those plants and animals, and it's going to run out. Like they were saying, at most optimistically to last for another 80 to 100 years, and we need to look further than that. So the answer is D. Any comments on that, Sondata? This was a hard question. Actually.
No, but 73% of them got this right.
Okay, that's great. That's great.
So nobody thought that it's mixed with fossils, but some of them thought the other two are. The other two statements are correct, of course. Just that's not the reason why they are called fossil fuels.
Yeah, that was just a factoid so that people know, like we still depend on plants even for the coal, right? So which of the following is not a renewable source of energy, guys? It's not a renewable source of energy. Is it hydroelectric power, wind energy, natural gas, and solar energy? Guys, hydroelectric energy runs on rivers, and these rivers are perennial. You know the water cycle, right? The water goes into clouds, it rains, goes back to the sea, forms clouds. So definitely it's a renewable source of energy. It has large negative effects on the environment because, dams stop water flow, it lays down a lot of forests, a lot of communities get affected. But that's not what we're talking about here. We're talking about the source of energy and it's renewable. Wind energy is renewable as long as the sun is going to be shining, guys, there's going to be wind. So wind, we are never going to run out of wind. Solar energy, again, as long as the sun is shining, there's going to be solar energy. So what is not renewable is natural gas, guys. It's called natural gas, but it's also a fossil fuel. It's basically, instead of coal, which comes as solid, it's gas. It comes as a gas. So natural gas is not a renewable source of energy. I don't know if people got this one correct because the not is
82% of them got this correct.
That's great. I'm really happy that people are understanding, natural gas is not renewable, even though, it causes less pollution, etc. Does it take 20 years, 200 years, 2 million years, or 200 million years? Okay, guys, this was like answer is like 200 million years. Basically, that's the amount of time required to build up the kind of pressure and temperature to create this coal and oil. And I think in 300 years, we have used all the coal produced in the last 200 million years. So you can imagine the pace of development. Let's see how many people got this one right.
Yeah, so this one, many of you got it wrong. Only 53% got it right.
But even if they said 2 million, it's fine. What did they say? 20 or 200?
They said 200 years, 2 million years, and 200 million years.
Yeah. Guys, 200 years seems like a lot of time, but it's nowhere near enough time to create these fossil fuels, all right? And that's why it's so important. That's why it's called non-renewable. Otherwise, every 200 years you can make the coal. ऐसा नहीं काम करता. It's really doesn't, because we need to shift to more renewable source of energy while making them reducing their bad impacts. Now the next question is 100 watt bulb running. Guys, if you followed my calculation, you should have got this one right. 100 watt bulb running one day is equal to how much coal? 1 gram, 100 gram, 1000 gram, or 1000 kg. The answer here is 1000 gram. So a rough estimate is one bulb one day 1 kg. And you can see how much a fridge or your computer, how many watts it consumes, and you can then calculate how much kg. Like I told, I consume 50 to 100 kg a day, which is ridiculous. What about this one, Samdata?
This one is 55% of them only got it correct. So
And
people have said
others
all
were
kinds
saying
of
like
things.
less.
1 gram se leke 1000
Okay.
kg tak.
Guys, we'll be sending the calculation to everybody in the links. Please do the calculation yourself and check it out. It's very interesting. And the final one is, what is carbon footprint? Is it is it total amount of greenhouse gases generated by our actions? Is it a popular brand of footwear? Is it total amount of fossil fuels used in our actions? Or is it a type of photocopy or Xerox machine? I think the person who made this question has some imagination. Okay, so that it's not a popular brand of footwear, guys. That carbon is with a K, and it's not a type of photocopy. I just put that because you have a carbon copy. The important thing to know is it A or C? It's basically a carbon footprint which relates to amount of greenhouse gases that generated by your actions, because finally it's the greenhouse gases that cause the issue. So the answer is A.
However, many
And
of them also thought that it's C.
yeah, that's a technical thing, guys. Yeah, fossil fuels that, but typically a carbon footprint is how much gases you release, because you don't just burn coal. There are also many other ways in which you produce the CO2 from many other sources, all sources of carbon. So the carbon footprint basically comes down to how much CO2 you are producing, how many greenhouse gases you are producing. So that's something to keep in mind. So with this, I think I'm very happy that many of you got all these questions right. Please share this quiz as well with your other friends who might not have been able to stay till the end of the session. I think we'll have the question answer session now, and then we'll finish the session. Gaji? I'll just stop sharing.
Yeah, so we are back, Deepa. So I was going through the comment section. This time, they're a of excited. I think we stretched it out a little bit. Sorry for that, guys. Those of you who had to leave for lunch or online classes, please come back and watch our session. It's recorded and will be there in YouTube. Deepa, we have some questions from the audience. Are you ready to take that?
Sure. I'll try my best to answer.
Yeah. So the first question is a very good question. It is how, from Muskan Thakur, how we can save energy.
How we can save
energy, yeah.
Yeah, you can save energy by being, I think we covered that in the games and quizzes with Saket. So, be mindful of how often you switch on the lights in your house and how you leave the fridge door open, how your devices are on more constantly than they need to be, switch things off. In terms of transportation, be mindful if you can bike somewhere, if you can use your cycle if you have, as opposed to using a car. And if you are taking a car, make sure car is full of people as opposed to a single person going from place A to B. Be more economical, that you can transport more people, just like a bus. And if you're using a bus, see if the city asks your politician to buy hydrogen fuel cell buses for transportation. They do exist in Bombay, where I live. The public transportation, there are a few buses now running on fuel cells, or there are electricity-based buses as opposed to ones that run on diesel. So, all of us can make little changes. Think about the food that you buy. If you buy imported avocados or imported grapes from California, they have a larger carbon footprint because those grapes were grown in California, they were transported here, they spent a lot of carbon dioxide or released a lot of carbon dioxide for those grapes to reach your table. Instead, buy grapes that are locally grown, all right, food that is locally grown, so that they have not have a large carbon footprint associated with that.
Thank you, Deepa. Also, I think that from this session, it's very clear that where possible, we should definitely shift to renewables. And also, like from the calculation that Saket showed, we should be really aware of how much energy we use and try to bring it down. So that can be the simplest way of saving energy. Thank you, Muskan. Now, the next question is from Uday. Uday asks, as I know, nuclear energy emits a lot of heat do for a long time, then can't we use it as an energy source?
But that's exactly what a nuclear power plant does. The energy inside that nuclear reaction, the nuclear fission that happens, is exactly that. Heat is captured and converted into electricity. So that's exactly what he says. The only problem is, in addition to heat, we have radioactive waste, and that is the problem.
So thank you, Uday. And the next question is from Jitendra. Jitendra has rightfully pointed out that we are a blue planet, which means that we are covered by water all sides. So can we not use tidal energy as our main source of energy?
Okay, so we can use water in a lot of ways. Tidal energy is obviously there. The game that Saket showed is useful, and people are trying to do it. But installing these generators is not easy, as you can imagine, because you need to install them where the tidal mechanical power is huge. And for that, you have to go to rough seas to install these things. So there's a cost associated. But you can use water in other ways. Like I said, what the work we do in our lab, we use water currently to try and form hydrogen gas. So using all the water that is around us, can we find a way of converting water to form hydrogen gas? Because hydrogen gas is a very important replacement of gasoline and diesel. So that is another way that you can use this important commodity on our planet.
Yes, yes. Thank you, Jitendra. And the next question is from Supriya. Supriya asks, have we made something out of useful out of carbon yet as for a long permanent usage?
Plastics. All the plastic you see is made out of carbon, okay? Every plastic item you see, and I'm sure when you look around your room, your computer, your pen, your table, you will be surprised how much plastic. And that is long term, okay? So, but the problem is we don't use the plastic all the time. We throw away the plastic bags. We throw away the plastic Tupperware, and what ends up happening, those plastic items are burnt in an incinerator in the garbage dump. You know, your city management takes all the garbage and incinerates it. And if the garbage has lots of this plastic, what happens? It releases CO2.
Yeah, yeah. So that's a very interesting answer, Supriya. Question, Supriya, and also an interesting answer from Deepa. So I've heard that the scientist who made plastic, he actually designed it to be used for a long term, but somehow it ended up in the oceans later, for which he really felt guilty. So who asked it, but the question is, what can the government do to reduce energy wastage?
What can the government do to reduce energy wastage? Wow. Yeah. What can the government do? Government can be more committed to climate change. Right now, they're not. The science exists, technologies exist to make better, to make coal more efficient. Old coal power plants are 20% efficient. Newer plants will be much more efficient, but they need to change it. They need to rebuild better plants. Means money is needed. In all these cases, it's all about money and finances. So there needs to be a commitment from the government. Now, the government will only be committed to doing things in a more environmentally friendly way if the population around them forces them to do it. Okay, if the population is not concerned and keeps bringing the same government back to power, then the government will say, well, whatever I'm doing is good enough for them, so why should I invest more money in these resources? So making more efficient uses, generators of electricity, even if it's coal, they can do a better job, okay? Even if it's coal, but definitely they need to move away from coal, and they need to make, solar plants. They don't want to make solar plants because it needs more money to do that.
Yeah, so with that, I think the questions are over. we don't have any more questions, but it was very interesting that many of the questions that students asked in the comment section, we already happened to discuss that in the course of our session. So yeah.
One big thing I think I didn't touch on, I just want to mention, there's another thing you can do with CO2 rather than just converting it to diesel. You can also sequester it. You can capture it in a sponge, okay?
Okay.
And hold on to it and bury it underground. So there's another way of.
I did see a question related to carbon sequestration. I'm not sure by which student, but yes. So she did ask, can we use carbon sequestration to store carbon for later use, something like that?
So there are these materials. Think of it like a sponge. Just like a sponge holds on to water, you can make these materials that can hold on to carbon dioxide. Okay, these are various kinds of porous materials, and what you can do is you can sequester a lot of carbon dioxide inside these materials and then bury these materials underground. So basically it's trying to remove a lot, and believe it or not, this is a very valid and important area that a lot of governments are using, because converting CO2 is not, and plants can only do so much photosynthesis that we're still releasing more carbon. So basically what they're asking is all the factories, all the thermal power plants with their chimneys releasing all the CO2, instead they put these materials at the top of their chimneys, capture all the CO2 before it escapes into the atmosphere, and then take that captured CO2 and bury it underground. Okay. So that's a very active area of trying to be implemented.
So thank you, Deepa. I think we've gone through most of the points that I wanted to cover. And I think for me, the key takeaways from this session is that definitely I have a better clarity on what is energy and what are current sources of energy that we use in the country, and shift to renewables is a must. Like, it is an inevitable thing. We will finally have to move to use renewables, and there is a lot of technological advancement that is possible in this field. So it is also, you can also see it as a potential to do more research. And that is definitely the way to go for us. And even if when we use coal as a source of energy, there is much better ways we can conserve it, consume less or sustainably, which is a very easy thing for us right now to do sitting at our homes. So that's for me the major takeaways from how energy can be used and what is its very close relationship with climate change. So I think we are very happy with how we have dealt with the session, and we have answered most questions.
So
anything to add on that?
Yeah, so thank you all of you, Deepa, Gayatri, Saket, and all the lovely bunch of students and teachers we had here. I think it was an extremely engaging discussion that I saw in the chat box today. People asked very pertinent questions. People came up with many innovative ideas. And talking of those innovative ideas, in November, we will open up the challenge for you to submit these ideas on how you can tackle climate change. So the details of those will come out in November. So keep an eye. All of you probably anyway receive my emails every now and then talking about what session will come up. Similarly, when the challenge is open, you will also get an email on what the challenge is like. But definitely there will be a part where we will want to know from you what kind of technological solutions you have in mind to deal with climate change in your local ecosystems. So do submit. And there will be other things in the challenge as well. Some of them will be around what kind of problems are even people in your local ecosystems are facing. That will require you to go out and meet people and collect data from them. So there are all kinds of things that you can do in this fight against climate change. And I'm so happy that we are building that community so well. So that's all for today, and we will be meeting again in less than 2 weeks. And thank you so much for joining us today in spite of all the problems that we had on Saturday. Thank you so much. Bye-bye.
Bye.
So did you stop the streaming?